Hello, boys and girls and Cougar parents. We are wrapping up Unit 6, Geometric Concepts, with similar polygons, and specifically similar triangles. As we begin to look at these relationships and understand the relationships between similar polygons and triangles, we'll see that it is a very useful and practical skill to have. Okay, let's take a look at these triangles. Okay, let's take a look at number 1 in our work packet here. We've got similar triangle worksheet. It says state whether or not the following triangles are similar and support your answer. Okay, well, first of all, if triangles or polygons in general are similar, that means first of all that their corresponding angles must be equal, and then you're going to find that their sides, okay, are proportional to one another. Well, let's take a look here. We only have the angles to work with. So given the angles, angle A and angle D, they correspond to one another and they're equal. The question we have to ask ourselves, okay, is angle B, does that correspond? It corresponds with E. Angle B and E correspond with one another, and angle C and F correspond to each other, okay? Those are corresponding angles. Now, these corresponding angles must be congruent. They have to be the same in order for this to truly be similar shapes. So let's test this idea. So if this is the case, then I would say, okay, angle E has to be also 75 degrees. And let's see if that works. I should be able to take these three angles, 35 degrees plus 70 degrees, 75 degrees plus 70 degrees. And when I add them all up, I should get 180. If that works, if that's the case, then it's pretty, I think we can say that these angles, or these triangles, are similar. Okay, 5 plus 5 is 10, plus 0 is 10, carry the 1. And then I've got 1 plus 3 is 4, 4 plus 7 is 11, and 11 plus 7 is 18. So we have 180 degrees. So I think this works. Okay, these two triangles definitely can be similar because the corresponding angles are congruent to one another. Okay, boys and girls, let's take a look at 2A. 2A is asking us, are these two triangles similar? Well, the first thing that I can check off is according to this, this angle and this angle, those corresponding angles are congruent, and by the symbol given here, these two angles are also congruent, those corresponding angles. Therefore, that would force our remaining third angles, those corresponding angles, also to be congruent. So we can check off the angles are all congruent, but let's take a look at the sides. Okay, well, we would have to say that this side right here, okay, what we're going to do is we're going to set up a proportion. Okay, now the sides, the corresponding sides don't have to be congruent or equal, but they do have to be proportion. So what we're saying is the ratio between this side and this side, side 3 and side 5, has to be proportional to the ratio of side A and side 15. Okay, because these sides are corresponding to one another. Okay, so what we'd have to do is we don't know what A is, but to make these two triangles similar, A would have to be in proportion to side 3. So there's a couple different ways here. What I'm going to do is I'm going to cross multiply. Okay, I'm going to say, okay, 5 times A, whatever size A is, the cross products have to be equal, would have to be equal to 3 times 5, which would be 45. And in order for this to be true, I'd have to solve the equation, divide both sides by 5, and A would be equal to 9. Okay, so if A is equal to 9, okay, then these two triangles are similar because the corresponding sides are in proportion to one another. Now, some of you might have just wanted to do something like this, say, hey, okay, to make these two equivalent, what happened when I went from 5 to 15, I multiplied this by 3, so I would also have to do the same to my numerator, multiply that by 3, and A, that's an A, it looks like a 9, A would have to be equal to 9. Okay, either way, for these two triangles to be similar, side A would have to be 9 to keep the corresponding sides proportional to one another. Let's take a look at number 3. Assuming the two triangles are similar, find the tower's height from the given measurements below. Okay, I love these types of problems. They're really simple. You just have to see how the different corresponding sides measure up and set up a ratio. So this is my mystery. Whoops. This is my mystery side over here. I don't know the height of this building, but I know the height, okay, in ratio to its base, which is 8, okay, 8 is given right there, has to be equal to the height of this triangle in ratio to its base, which is 0.2 meters. So once again, it is cross multiply, and when I cross multiply, I get, okay, 8 times 1 is 8, and that's going to be equal to 0.2h. Okay, so what do? I divide both sides by 0.2, or 2/10. I'm going to go over here just to show what's going on here. I have 8, and I'm dividing it by 0.2. I can't leave 0.2 in the divisor like this, so I have to make it a whole number. And what I do to the divisor, I need to also do the dividend. So I move my decimal point out here and fill that in, make it 80, and 2 goes into 80 40 times. So h is equal to 40 meters. That is the height of our building. Pretty simple. Let's take a look at number 5. Tanya is 1.3 meters tall. She stands 7 meters in front of the tree and casts a shadow 1.8 meters long. How tall is the tree? Okay, well, the height of the tree, that's what we're trying to figure out. That's unknown, okay, which is the height of the big triangle. Okay, now it says that she stands 7 meters in front, so that means from here to here it's 7 meters. Okay, she stands 7 meters in front of the tree. She happens to be 1.3 meters tall, so that means from here to here approximately, that's the height of that triangle. And then the shadow that she casts from here to here is 1.8 meters. Okay, so there's our two triangles. We have a big triangle with a height that's unknown, okay, but yet it has, the big triangle actually has a length, if we have to add these two together, be 8.8 meters altogether. Okay, so that's the base of our big triangle. So the height of the big triangle is unknown. The base is 8.8, and that's got to be equal or in proportion to the height of Tanya, which is 1.3 meters, divided by, or I should say, over the length of her shadow, which is 1.8 meters. Okay, we're just going to use cross multiplication. When I cross multiply 8.8 times 1.3, okay, 3 times 8 is 24, carry the 2. 3 times 8 is 24, plus the 2 is 26. Put a 0 there in the placeholder. And then 1 times 88 is going to be 88. I add it all together. I get 4. I get 14, carry the 1, and then I get 11. I have 2 decimal places in my problem, so I should have 2 in my answer. So 8.8 times 1.3 is 11.44. And that's got to be equal to 1.8h. That's when I multiply. Okay, the cross products, if I have two ratios that are proportional or equivalent to one another, then the cross product should be equal to one another as well. That's what I'm doing there. So now I have to solve for the variable, which will give me the height of the tree. I divide both sides by 1.8, sorry. The 1.8 cancels out, and the height is going to be equal to 11.44 divided by 1.8. I can't have a decimal in my divisor, so I got to move the decimal point over 1. I do the same thing in my dividend. Okay, 18 goes into 114 6 times. 6 times 8 is 48. Carry the 4. 6 times 1 is 6 plus the 4 is 10. I subtract. I've got to regroup. 14 minus 8 is 6. Okay, and then 0 times 0, yep, we're good. Then I need to bring down my 4. Okay, 18 goes into 64, I'm going to say approximately 3 times, and that's going to be 3 times 8 is 24, and 3 times 1 is 3, plus the 2 is 5, and I get 10. And I'm going to stop right there. I'm going to say the height is approximately 6.3 meters. Because I have a feeling that this decimal is going to keep on going for a while. Okay, you should be good to do the rest of the problems on your own. Just remember to set up these compare the two ratios that have to be equal or proportional, and you'll be in good shape. As always, I hope that was helpful, and if you have any questions, please bring them to class tomorrow. Looking forward to seeing you then. Bye-bye.